Good morning and welcome to the hub at URY, where today I'll be showing you around the usage of URY's Tandberg satellite receiver. It's a very basic little thing, but we use it to receive IRN because it has a digital EBU3 output that we can use to get digital audio. Sorry, I said EBU there, no, AES3. So the thing about the Tandberg is it's a professional piece of gear. This particular one was ripped out of Lakeland Radio quite a number of years ago now. It's actually quite old. The company that makes it is no longer in business and now basically part of Ericsson, although it's a bit more complex than that. You can find the manuals still on the internet, but they're a bit complex and I wouldn't blame you for not needing all of them. I'll show you everything you should need to know in order to fix URY's stuff. So the menu system is very simple. Sort of, if you go left, you get back further towards the root menu, and if you go right, by pushing the right button to go further in, you get more advanced options. So you can see this is where it's usually left, on the status menu, showing the strength of the satellite signal we're receiving. Currently, we're receiving a signal level of minus 30 dBms, that is minus 30 decibels relative to a millivolt from the satellite receiver on the roof of the building. Anything above this line here, or in general, minus 34 dBm, should probably be fine. We should be able to survive with that. So let's go back now towards the main menu, which we get to by jamming on the left. This is our main menu tree. We can go up and down by pushing the main buttons, and we have various options. We don't need all of these, but I'll focus on the ones that are important. First one to focus on is presets. Now that's important because I pre-programmed this Tandberg with a preset that has the IRN settings on it. If it ever loses its settings, say it gets hit by lightning or there's a power outage, then you should be able to go back to the normal setting by going here, select, first setting, IRN, and save. And that should bring us back to the normal settings. Second, this is the input setting. This is important because it deals with the actual satellite receivers itself. The Tandberg has 4 RF inputs on the back. Each of those is connected to a different output from the LNB, or low noise block down converter, or from the satellite dish outside the building. We need that because the signals from satellites come in at an extremely high frequency, and it's less good to be able to transfer that through the cables into the building, so we need to convert it down into a lower frequency if we'll use it properly. Now, this menu isn't important to us because this just lets you select you're using a satellite or a different type of input from the back. As I previously said, the Tandberg is a professional piece of hardware. It supports numerous things that we just don't need flatly. So we'll always be using this. So let's go in. You see, we have SMPTE 310 there. Don't need it. Now, this lets us select our RF sources. By hitting edit, we can cycle through the different things we need. The default should probably be RF source 2, as when me and Matt Stratford initially installed these RF lines a few months back from when this was recorded, RF source 2 is the line with the least amount of insertion loss, meaning that it probably is the best connection overall to be using. Now if I click off edit, we can see that nothing is saved. I'm going to go back to the default option. So let's go in. This is just telling us that an acceptable level of voltage signal is being received on the actual connection at the back of the service here, on the other end where all the cables go through. You can actually see, just about, if I stand up a bit, where the cables go through the building out the back there. They're the tangled mass just below the edge of the electrical cabinet over that way. Most of the time this shouldn't be important, but it's good to be able to know how to check your signal levels. Now, going further down, we can see that you have the LNB frequency. Now, LNB frequency is important because there are different frequencies that the Tandberg itself needs to calculate to know what the LNB is operating at. We need to know what frequency the LNB is operating relative to in order to know what it's down converting to. Now, satellite signals are transmitted in 2 polarizations. That means wibbling up or down, or right and left. And we can see that if we go into this is the actual frequency of the raw signal we're looking for. We will also be able to select 18 volts power forward to the LNB in order to select a horizontal polarization, or 13 volts in order to get a vertical polarization. Most of these shouldn't be important, but it is important if in the future IRN changes their frequency and we need to redo it. This is the symbol rate, basically just the bit rate the stream is transmitted in. This shouldn't be important and should be automatically detected at such a time as we have the receiver locked on to a suitable IRN signal. Search range should always be left up to full. This means in case of signal weirdness, like frequently happens in RF, we'll be able to lock onto the original signal much faster. And because we use quite a professional lab gear LNB, you should always keep this 22 kHz pilot tone enabled. This is just another frequency sent back up to the LNB in order to keep it locked on the right frequency. As a useful debugging step, you should probably try cycling through the RF sources if you notice that the actual signal level drops in the first place. During regular operation, you want to see something like this, indicating that we are locked onto a DVB-S or DVB-S2 multiplex coming from Eutelsat 9B. The 9 is because it's 9 degrees east from the, well, 0, I suppose. I don't know how latitude works. Next thing up is service. Now, you can imagine we have one big block full of ordinary channels being broadcast from the satellite. These aren't just things like IRN. We can see, if we scroll through the list, Absolute Radio is always on there, TalkSport's on there, and a number of BBC AM distribution feeds. Now, if you're wondering, why the hell are they on there? Good question. The basic reason is because this multiplex is of signals being transmitted back down to the UK is used to feed a number of outlying transmitter sites all over the place. So the BBC has a number of AM transmitters out in really far-flung locations. How do they get signals to them? Very simple, they use satellite, and they use this MUX too, as does Absolute Radio for their AM service, blah, 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 so on, so on. Now, you pretty much always want this to be locked onto IRN, which is currently on service 01160. That could change in the future though, and it's important to use sites like KingofSat or LingSat in order to keep up with what the current frequency is, should you lose it. You can see that IRN transmits two services. 4401, which contains on the left channel IRN1 and on the right channel IRN2. And 4402, which contains the stereo IRN3 channel. This is most frequently used as a backlink for the Vodafone Big Top 40 chart show, but it is what was previously also used for wireless group regional feeds. We don't need any of the other options in here, though hopefully we should be able to pick something up on this asynchronous data feed later on. Now, the only other thing that you should potentially need is this System tab. This lets us access some useful options like locking off the front panel so that it can only be operated from remote services like SNMP or an IR blaster. However, we should always leave it in this mode. Worst comes to worst, and particularly if the system is hit with a lightning strike like it has been previously, you should try to restore system defaults. These are kept on a ROM inside the system and will survive quite well. The customization key is a way that allows you to set all the settings of the receiver back to its previous state. We probably shouldn't need this, as we only ever need it to be in one state, receiving IRM. And right here at 7.3, system restart. Very useful because it fixes all sorts of issues. One final thing that you might want to know is how to route output. Now, if we were receiving a television channel, which is quite possible on this device, you can also output out of SDI, and potentially in the future this could be useful for things like watching the Brits or Eurovision, as the feed can be routed into URY's existing video feed patching system. But we're not too interested in that, because if I can get on here, as you can see, we can see the routing of the setup. We want it to go to the digital output in AES3, as that's where it enters our Dante audio over IP system. We have it routed to stereo, meaning that left goes to left and right goes to right, because this allows us to pick up both the IRN1 and IRN2 channels simultaneously. You can also monitor the quality of the feed we're receiving here. 48 kHz with a bitrate of 256 AAC LC is quite a good bitrate and will give us virtually flawless sound. Hopefully, that should be everything you need to know about the Tandberg. I rebuilt it pretty much from scratch a few years back. Some of it still works. If it doesn't, you can probably find an old one for under 20 quid on eBay, given enough patience. Although it will probably take a fair amount of time to set up, because it's a bit of a chunky bastard. And final odd tip, if the back button's being a bit squidgy, give her a whack. This thing was built in the 90s, she'll survive it.